Okay, good afternoon, morning, evening, depending on where you are. Um, it's been a while since I've done one of these, but yeah, here we are and here we go. So today's video will be on lesson 2 of unit 3, our stats unit, and we're going to do a couple things. So we're going to talk about different types of data, discrete, continuous, cumulative. So we'll define those down here. We're going to talk about different ways to display data. Okay, that's these ideas here. We'll talk about symmetry, 3 different types of symmetry. I think there's a mistake here, so we'll correct that. And then we'll talk about, this idea of a cumulative frequency table, what that is, and then a graph, and then just look at a couple examples. Okay? So let's get into it. All right, so the first kind of idea for you guys to know is this idea of 2 different types of data. Okay, and by the way, we're assuming we're dealing with numerical data. Okay, there is categorical data, but we're dealing with numerical data. Okay, so I'll actually put that in here. So we're going to only consider for now numerical data. Okay, and that's really, this. I shouldn't say that stats always deals with numerical data, but actually it kind of does. So anyway, so we have these 2 terms listed: discrete, continuous. You can read this definition here. The way I like to think about it is that discrete data is countable. Okay, countable. So you could, in theory, count every possibility, right? If you're counting the number of students at GIS, that's discrete data because, it's a countable number, okay? Continuous data, and I don't know if we have this in here. Let me see. Well, a couple things. Yeah, so this is key. It's not possible to make a list of all the possible outcomes, right? So this basically means that there are an infinite amount of possible values. Okay, that's only for continuous data. In discrete data, since it's countable, there's a finite number of possibilities. It might be a huge number, but there is a finite amount. Okay, with continuous data, that's not true. It's infinite. Okay, and the way we can think about it is not countable but measurable. Okay, and we could be as specific as our measuring device. So for example, time is continuous data. Your height from when you were born to now, that is continuous data because it's measurable. And in theory, you went through every possible height from the height you were at when you were born to your current height. Okay, that's kind of how I think about it, right? Discrete means it's countable, finite possibilities. Continuous is measurable, infinite possibilities. Okay? Hopefully that makes sense. So here we've got these different ways in which we could display data. So we have a frequency table, a column graph, a dot plot, and a histogram. All right, the really, to me, the 2 that are a little bit confusing, or not confusing, but there's a distinct difference there, is the column graph and the histogram. Okay? And basically a column graph you're going to use for discrete. Sorry, I can't write here, guys. This is pretty bad. Discrete data. Okay, so right here is the column graph. And what you'll notice there is in between the columns, right, you have some gaps, right? Because if we're measuring the number of times that somebody went to a supermarket, well, it can be 1 or 2 or 3 or 4 or 5. It can't be 1.7. It can't be 5.2. All right, so column graph you're going to use with discrete data. The histogram, it looks the same, but you use with continuous data. Okay, so this one right here, right, this is your histogram. histogram. Okay, so that we use for again, I can't write, guys, it's messy, sorry. We use for continuous data. All right, and hopefully, yeah, we can see, right? Because if you're measuring the weight of something in kgs, well, it could be 1, it could be 2, it could be 1.534, it could be 1.76, 3333259, whatever, right? So we have all these possibilities, okay? And what we're sorting here really is the frequency, the number of times that there is a weight between 1 and 2, right? So this, I'm assuming, will go from 1 kilogram all the way up to as close to 2 as possible, but the minute that you get to 2, that's grouped now in this next kind of column here. Okay? Frequency table, that's just right here. Sorry, I want to make that another color. Okay, and there is a difference here. So we have, here's your number of people. There's a tally where you manually kind of count everything, and then you take the tally and you just make a nice cleaner frequency. Okay, and that leaves the dot plot, right? The dot plot is right here, and if you notice, we do have a difference again, where the dot plot, we're using this for discrete data, right? This is the number of nights that we're measuring. Number of nights of what? I don't know. Maybe number of nights that you had fun doing math homework. Actually, no, sorry, it should be the other way. It should be the number of nights that you didn't have fun doing math homework, because we want those to be min. And then the frequency table, yeah, this is measuring the number of people between 10 to 19, 20 to 29, 30 to 39, 40 to 49, 50 to 59. So I'm actually thinking that this is ages. Okay, so I'm actually going to put that in, because if I do that, then it does become a continuous data set. So, but maybe it's just the number of people. Yeah, I think that makes sense. But I'm gonna stick with that. Okay, you could use a frequency table for discrete data, but you can't use a dot plot for continuous data. All right. Going on. So first question here. Which of the previous displays is best used for discrete data and continuous? Well, we kind of just talked about it, right? A column graph you have to use for discrete data. A histogram you almost always should use for continuous data. And a dot plot you have to use for discrete data. So I'm going to say for discrete, the dot plot, and the column graph. Okay, and for the continuous data, usually that's going to be a histogram, and then I'm going to put star, maybe a frequency table, but that just really depends. Okay, depends on how you sort your data, and hopefully you guys can read that. All right, this next example, right? So this is something that we want you to be able to do, is just take data, examples of data, and know, is it discrete or continuous? Okay. So if we look at the shoe size, well, yeah, that's definitely discrete, because even though you can have decimals, you can't have a, you can't have a decimal that's like, you can't have an infinite amount of decimals between two sizes, right? Usually you have half sizes. So that's discrete. Let's see, what else? Foot length, no, that's length, that's measurable. Students in a class, yeah, for sure, that's discrete. Hopefully we don't have any partial students in class. Distance traveled to school, that's measurable. Children per family, that's also discrete. Okay, so these three in black are discrete. I'll put the continuous data values in blue. Okay? But again, if you just start thinking, what can I measure and what can I count, I think that'll really help you with being able to differentiate between these two. Okay, so now Actually, I'm going to end this video now, and then I'll start a new one on skew and cumulative data. Okay, so see you in the next video.